Hi, this is a quick getting started tutorial for Spin Robotics tool. In this tutorial I will presume that you have everything correctly connected and the tool is white here. So you'll have figured out your IPs and stuff like that. And that you are using these M4x16 screws that should be included with the kit. Because we'll be using the predefined programs on the bridge, so we don't need to set up new programs for this tutorial. The goal is to get to a program that runs like this, where the first step is picking up a bit, then picking up a screw, inserting that screw, and putting back the bit. Right. So, first things first, we will create a new installation. So, let's keep the default setup. Use for now. And we'll have to initialize our robot again. So there's just a few things we'll need to set up. We'll first need to connect to the spin bridge. Right. Then, with the correct EuroCap installed, you should just be able to see the correct TCP. I'm using an SG35 here. Set that as the default TCP. That'll also set it as the currently active TCP. Same with the payload. SG35, set that as the default. Here you need to be aware that you need to also click the Set Now button if you have the tool attached, presumably. Otherwise, it's not applied. In I/O setup, you'll be here in all, and then on a configurable. We'll set up number 7. This is presuming that you have the wires correctly attached in the control blocks. Number 7 is the button on the back that we want to map to free drive. And number 5 is the button here on the front that you can use for whatever you like. You can either map it to something here. You could, in theory, use free drive or start stop. The only caveat here is that these start stops only work when your program is when your robot is in automatic mode. You are also able to use this configurable input as an input for your program, so you can use it here in your program tree. And that's about it. Now we're ready to do the EuroCap installation. Let's see here. First things first, we're going to set up our feeder. And we're going to do that by putting in our teach pointer, locking that in place, and then clicking Add New Feeder. Give it some name. I usually name it after what's in the feeder. So we are, as I mentioned, using the M4 16mm screws. Make sure to put in a screw length, and then we'll teach the position. When you teach these positions, what I usually do is that I get close, and then I use the Align tool on UR, and then I go back and use the free drive button again to move the teach pointer all the way into the screw. Here for the feeder, you'll want to be careful that you don't move around the screw. The screw is held very loosely in the feeder here, and you'll want to make sure that you're exactly in the middle of the position that it's left at. And make sure to align if you've moved things around. And OK. And OK again. Here we have the possibility to verify the position that we just taught. This is useful, exactly. Wait for the noise to be over. This is useful for verifying that you don't move around the screw. So what I usually do is I verify the position where you have the move above screw. And then when you move 2 screw, lower the speed. And keep an eye on this here, where it's moving down. And make sure that when it engages with the screw, it doesn't move it around too much. I think I'm happy with that. Put the speed up again while we remember. And then we do the same for the bit changing station. Add a new station, give it a name. Let's just call it my station. Teach point A. Now the bit changing station can be a little more forgiving with the positions, but still be aware that when you move, use the align tool, sometimes the robot can be in a position where it sort of pushes down into the table a bit and you might not be teaching the position you think you are. What I usually do in these situations is just make sure to click free drive button before I save the positions and make sure that I'm still aligned after doing that, and then saving the position. Because in that way you know that all the joints are relaxed and the position you're teaching is where you think it is. We then do the same for position B. Align it. Click the free drive button to make sure all the joints are aligned, are relaxed, and make sure that the robot is still aligned. Save that position, and same with position C. Align. Make sure it's loose. Make sure it's still aligned. Okay, and okay. And then again, we want to verify. When verifying the bit station, you verify that it correctly identified position B. What it's actually doing here is that it's calculating where the B position should be based on the other positions that you taught, so that we know that the math behind the scenes went right. So you just want to make sure that it hits the whole of B. Okay, I think we're happy. While we're here, there's also the help tab, where there are QR codes to get to the online manuals if you'll need some help there. Okay, let's go to our program and delete everything and create it from scratch. So, the first thing we wanted to do, let's just get the tool back here, was that we want to attach our bit. So we'll select our station. And for this program, I know that the bit in my station that's used for these screws is the one that's in the first position. So we select that one. Then we'll want to load our screw. We then select our feeder. And then we'll want to insert that screw. Here we select our tool. This is just groups. And the pre-existing programs for the M4x16 screw. And then we teach the position, just like all the others. Make sure to align. Make sure that all the joints are relaxed. It's still aligned. We're happy. Now, the drive screw node can be a little large, and that can make the program a little hard to read here. So what I like to do is put in a folder, and then I'll just cut and paste my drive screw node. Oh, undo. Our drive screw node into this folder. Let's give it some good name. Say insert screw, because then we have the ability to hide it. And we want this to be long because we want all the control over things here. The drive screw node is sort of split into 3 parts. The first part is the approach movement. This is how the robot moves all the way to the start position of your program. What we use is the safe approach movement. If you want to do your own movement here, there is this program start pose defined that you can use. Then the program starts. That's this drive screw part of the node. This drive screw part is what you have defined on the dashboard In this case, we use the default programs, but it's still what's controlled by the bridge. After that, then depending on our screw program success, we either go into on OK or on not OK. If our program, all our steps went well, and the verification of our torque was successful, then we go into the on OK. Otherwise, we go into the not OK. So this gives you the opportunity to handle different badly inserted screws differently from well inserted screws. If something very bad happened, like losing connection or similar, then you go into the fault handler. But that's all quite a lot, so let's hide that tree. After we've inserted our screw, then we'll want to detach our bit. So we pick the detach bit, pick our station, and put it back to the original position. Then we'll want to release our teach pointer. And we'll move our screw, hit it. And now we'll see if we taught all our positions correctly. So first we pick up our bit. We then pick up our screw. We insert our screw. That went well. And we put back our bit. Great. So that's how you get started with Spin Robotics.